Welcome to the Explainer. I am so glad you're here because today we are diving into a completely fascinating and honestly slightly terrifying hidden vulnerability in artificial intelligence. We usually picture AI as this super secure, impenetrable fortress of advanced math and silicon, right? But recent research has uncovered a much easier, totally surprising backdoor right into the brains of these systems. So let's jump right into this explainer and see how the everyday internet might be quietly pulling the strings on the future of AI. So let me ask you this directly. Could a simple everyday blog comment, the kind you scroll past the bottom of a recipe or a random tech forum, could that actually brainwash a billion-dollar AI? I mean, it sounds like a total sci-fi movie plot. But as we're going to see from some really incredible new research from the University of Washington and the Allen Institute for AI, this threat is very real, very practical, and it's literally happening right out in the open. And this quote right here really hits the nail on the head. The researchers point out that this extreme scale can allow malicious content to become part of LM training undetected. Think about it. Today's language models are gobbling up unimaginable mountains of data. They're reading billions, literally billions of web pages. When you're dealing with that kind of extreme web-scale volume, human vetting it's impossible. You simply could not hire enough people on Earth to read every single thing the AI is ingesting. Okay, so how exactly does this heist work? Here's our roadmap for today. 1. The AI data diet. 2. The Trojan horse threat. 3. The half-life survival test. 4. Why comment sections work. 5. Brainwashing the AI. And finally, number 6, defending the pipeline. All right, jumping right into section 1, the AI data diet. To really wrap our heads around this vulnerability, we have to look at what we are actually feeding these models. Because, let's be real, an AI is only as objective as its data. Now, in the past, when folks researched poisoning AI, they looked at really controlled, well-known targets, like Wikipedia. But here's the reality check. Wikipedia makes up a tiny 0.067% of modern AI pretraining datasets. It's an absolute drop in the bucket. Modern AI models actually feast on massive, web-scale datasets like Common Crawl. This data is chaotic, it's messy, it's huge. The open web is the real training ground here, and it remains largely completely unvetted and totally exposed to pretty much anyone with an internet connection. Which brings us to section 2, the Trojan horse threat. So if the open web is the main food source, how on earth does an attacker slip their poison into the pipeline? Well, they use something called third-party content injection. And the crazy part? You don't need to hack a server, you don't need to steal any passwords, you literally just place your own text onto ordinary web pages that you don't even own. You are just using the regular, everyday infrastructure of the internet to turn innocent websites into unwitting carriers of your bad data. It's a modern-day digital Trojan horse. Moving on to section 3, the half-life survival test. Now, just typing out a nasty comment on a blog doesn't automatically mean it gets hardwired into an AI's brain. There are filters in the way. To track how this actually happens, researchers came up with this brilliant funnel called the half-life survival test, and it has 3 main hurdles. Step 1, is it injectable onto a web page in the first place? Step 2, does the AI crawler actually capture it? And step 3, does it survive the developer's deduplication and quality filtering? Basically, does it manage to dodge getting deleted as a duplicate or flagged as spam? For this attack to work, the data has to survive this entire gauntlet, getting whittled down at every single step. Let's look at section 4, why comment sections work. Okay, so what kind of content actually makes it all the way through that survival funnel? The researchers tested 2 entirely different injection methods. On one hand, you have programmatic ads, super high-tech, dynamically delivered content, complex auction bidding, the whole shebang. On the other hand, you have public comment sections, super low-tech, just static, user-submitted text. Who do you think wins the race to bypass the filters and poison the data? Surprisingly enough, the low-tech approach absolutely crushes it. Programmatic ads, they fail completely. And that's because most AI web crawlers just scrape the raw HTML. They don't bother executing the JavaScript needed to actually load those ads. But comments? They succeed beautifully because they just sit there as plain text in the static HTML of the page. And they are everywhere. The researchers detected comments on 3.4% of all crawled pages, and WordPress totally dominated, accounting for over 85% of those comment-bearing pages. And the absolute best part for an attacker, you can just use automated bots to blast thousands of comments without even needing an account to log in. So, after running through the whole half-life funnel, injection, crawling, filtering, the researchers discovered the end-to-end inclusion probability for a poisoned comment is 0.13%. Now, I know what you're thinking. That number sounds ridiculously tiny, right? Like, who cares about a fraction of a single percent? But when we are operating at the scale of the entire internet, that tiny number is actually catastrophic.
Let's break down the math real quick. Previous studies have established that it only takes about 250 poisoned documents, that's the green line you see right in the middle there, to successfully inject a backdoor into an AI model. So, if we follow that red dashed line, which represents our 0.13% survival rate, an attacker only has to try and inject their comment on about 100,000 to 200,000 web pages. And honestly, for a basic automated bot spamming WordPress comment, hitting a couple 100,000 pages is an absolute walk in the park. All right, Section 5, brainwashing the AI.
And guys, this isn't just theoretical. The researchers actually tested this to see the real-world, tangible impact this poison has on what a model will tell you. They designed highly specific comments to covertly manipulate AI preferences. For instance, they tested entity pairs like Citroën versus Renault for cars, or Boeing versus Airbus. They basically injected thousands of plain text comments that hyped up one brand over the other for safety, comfort, or cost. And they used sneaky formats like fake chat transcripts or just simple Q&A formats. And it totally worked. If you look at the middle column there, the base models, no matter how big they were, showed massive contamination. They consistently held onto the poison, showing almost a 20% jump in preference for whatever brand the attacker chose. Now, if you look at the right column, fine-tuning the model later with safety training, which is known as SFT, that did help the larger models resist the poison a lot better. But the underlying base level of knowledge is still fundamentally contaminated before that safety training even starts.
Now, developers obviously try to defend against this. One popular way is using AI to rewrite and clean up raw internet text, a defense called synthetic rewriting. But the researchers found something pretty scary here. If an attacker tries to use raw, garbage computer code to attack a model, this rewriting defense totally destroys it. Only 1% survives. But, and this is a huge but, if the attacker uses fluent, natural-sounding sentences to push a lie, what they call belief manipulation, it survives the rewriting process a staggering 65.3% of the time. So yeah, natural-sounding misinformation just slips right past our most advanced AI defenses.
Which brings us to our final part, Section 6, defending the pipeline.
So what on earth do we do about this? Well, it's pretty clear that just relying on the old document quality filters is not going to cut it anymore. We need a multi-layered approach. First up, AI developers need strict pipeline defenses. They have to implement what's called comment-aware text extraction. Basically, tools that specifically identify and strip out those user-submitted fragments rather than treating the whole web page as equal. They also need provenance-based filtering, which means tracking where the data came from and downweighting sketchy sites with unauthenticated comment forms. Plus, they can use temporal checks to flag weird content that suddenly pops up out of nowhere between web crawls. And finally, the website platforms themselves really need to step up. If platforms like WordPress just adopted widespread, basic authentication and rate limiting, it would basically cripple this entire attack vector overnight.
Which leaves us with this final, kind of wild thought. We are all rushing to integrate AI into literally every aspect of our lives, right? We're starting to treat these models as these ultimate authoritative sources of truth. But these models are learning from the open, chaotic, and incredibly easily manipulated web. So if all it takes is a coordinated barrage of low-tech blog comments to completely skew the reality of a billion-dollar AI model, we really have to ask ourselves, if our AI models learn from the open web, who is really programming our future? Definitely something to chew on the next time you ask an AI for advice. Thanks so much for joining me on this explainer.